Today we're going to simplify radical expressions. This is kind of the culminating, like we're going to put everything together and maybe learn a couple new things as well. One thing that we need to remember is that you can take a radical and split it up using multiplication. So this thing is really the third root of 27 and the third root of z to the ninth. Okay, third root of 27, we can use our perfects chart for that. It's either on the chart or we can simplify it using the chart. So what is the third root of 27? 3. The third root of z to the ninth. There's like 5 different ways that you can think about this. I think 5. We'll see. One way is the third root of z to the ninth is the same as z raised to the 9/3. The exponent becomes the top of the fraction, the index becomes the bottom of the fraction. What does the fraction 9/3 simplify to? 3. So this becomes z to the third. Here's another way of thinking about it that's going to help with the next problem a little bit more. We can split this into the third root of z to the third times the third root of z to the third times the third root of z to the third. We still have all 9 z's. There's 3 of them here, 3 of them in the second one, 3 of them in the third one. 3 and 3 and 3 is 9. So all 9 z's are there, we just split them up into groups of 3. The third root of z to the third is z. The third root of z to the third is z. The third root and the exponent of 3 cancel each other out. You end up with z times z times z, which is z to the third.
Wow.
Ultimately, our answer here is 3z to the third. Okay, here's one more way to think about this, and this is the way that I typically, well, actually I'm going to do 2 more. Think of it as, how many times does 3 go into 9? 3 goes into 9 3 times. So think of it as dividing, 9 divided by 3. And this is easy right now because there's no leftovers. You can also use dots. Make 9 dots in groups of 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 3 full groups of 3, so it becomes z to the third, because there were 3 full groups. All right, let's go over to number 2. Let's try this one. This is the cube root of 8, the cube root of r to the third, the cube root of s to the 5th, and the cube root of t to the 10th. Okay, let's start with the numbers. Cube root of 8. Can we do the cube root of 8? Yes, it is 2. Cube root of r cubed. The cube root and the cube cancel each other out, and this gives us r. Okay. Mathematically speaking, the best way to do the third root of s to the 5th is to split it up into groups of 3. So we've got the third root of s to the third, that's 3 of them. How many s's would we have left? 2 of them. So 3 and 2 makes 5. We've split it up into one group of 3 and a group of 2 that's left over. The third root of s to the third becomes s. And this one, it's not a full group of 3. It doesn't cancel. It's going to stay the third root of s squared. Now, I feel like that takes a lot to write that all out, so I like to use dots instead. So I do 1, 2, 3, 4, 5. There's one group of 3. That becomes my s. And these 2 left over become the cube root of s squared. Those 2 are still stuck under the radical. You have to have a full group of 3 to break out of that radical, to cancel out that radical. Some of you don't need the visual, so you can think, how many times does 3 go into 5? 3 goes into 5 once with 2 left over. So there's one group of 3, that's the S, and the 2 left over are still under the radical. Okay, so t to the 10th, the third root of t to the 10th. Some of you who can like visualize this in your brain, how many times does 3 go into 10? 3 times, that's 9 with 1 left over. So it would be t to the third because it goes in 3 times with 1 left over. I prefer visual. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've got my 3 groups of 3. That becomes my t cubed. And this 1 left over becomes the third root of t. I personally like the dots. I think it gives you a nice visual that doesn't take you too long to actually draw. You could also say, this is the third root of t to the third, third root of t to the third, third root of t to the third, third root of t. That's 3, 6, 9, 10 t's. And then this is t, 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 and that thing. So t cubed, third root of t. Once you get this all simplified, we have to put all of this together into an actual answer. You have to start with numbers and letters in alphabetical order that are not under the radical, and then end with whatever's left under the radical, numbers first, and then letters in alphabetical order. So first, numbers and letters not under the radical. We have 2r S t cubed. Then we make a third root symbol and we do everything that's still stuck under the radical. S squared t. A simplified radical does not have any perfect cubes left under the cube root. We get all of those perfect cubes and simplify those out. Okay, next we are going to go to example 6. So turn the page and go to example 6 on the back. This is the fourth root of 12, the fourth root of d to the fourth, the fourth root of e to the 9th, and the fourth root of f to the 14th. I want you to try on your own. Now, 4th root of 12, I'll just tell you right now, that one might not simplify. It might just have to stay 4th root of 12, and that's okay. But try to simplify the others and see if you can put that together somehow on your own. Okay, the 4th root of 12, if you look in the fourths column, there aren't any numbers besides 1 that are smaller than 12. That means we can't simplify that radical any more than it already is. 4th root of d to the 4th. The 4th root and the exponent of 4 will cancel each other out, so that's just one plain d. For the 4th root of e to the 9th, how many times does 4 go into 9? Twice, that'd be 8, and there'd be 1 left over. So it would be e squared 4th root of e. Now, I prefer a visual because I don't trust my brain to remember all of that, so I'm doing groups of 4 this time because it's a 4th group. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's my e squared. Those 2 full groups of 4 become e squared. And the 1 left over is the one that's stuck under the radical. Okay, the 4th root of f to the 14th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I've got, it goes in 3 full times. That would be an F, not an E. And there's 2 left over, so I have the 4th root of F squared still under the radical. Once you have all this mumbo jumbo, first we put numbers that are not under the radical. Do we have any numbers not under the radical? No. Letters not under the radical in alphabetical order. So we have D, E squared, F to the 3rd. Then we write a 4th root, and we put the things that are still stuck under the radical. Numbers first, and then letters in alphabetical order. Okay, we have the 4th root of x to the 8th, the 4th root of y to the 11th, over the 4th root of z to the 6th. I want you to attempt to simplify each of those and put it in there. Give it a shot. Try. Pause the video. Try. So we simplify each of those. And you might think, all right, hey, this looks good. This is already in the right answer format and everything.
No.
Is this answer okay? Why is it not okay? There's a radical on the bottom. So here's the deal. We really, really want this to be the 4th root of z to the 4th. If it was the 4th root of z to the 4th, it would cancel out to just a plain old z, and then everything would be fine and dandy. We currently have 4th root of z squared. How many more z's would we need to make that the 4th root of z to the 4th? 2 more. So we multiply by the 4th root of z squared on the top and the bottom. For our answer, we've got x squared, y squared, 4th root of y cubed, z squared. You just combine those two radicals together. On the bottom, I want you to think very carefully about what we now have on the bottom. There's this z that we started with, and then this, we completed that group of 4, so now that green stuff becomes another z. So we now have z squared on the bottom. That's the original z, and then this stuff becomes another z. So z and z is z squared. Try number 7 on your own. Pause the video. Once you get it to this point, this needs to be the 5th root of h to the 5th. Has to be to the 5th this time because it's a 5th root. We currently have h squared. How many more do we need to get to 5? 3 more, so we multiply by the 5th root of h to the 3rd. So our final answer is the 5th root of g squared h to the 3rd over, how many h's are on the bottom now? H squared. You've got the original h, and then by completing that group of 5, you created another h, so now there's h squared on the bottom.
Is that 5 on the outside of it?
Yeah, that's a 5th root. Oops. Okay.